Let's begin with the class 12 mathematics chapter 1 relations and function. It's a continuation. So in the previous classes you have learned different types of relation, different types of function, and now we are moving on to composition of functions. Composition of functions, that is, you can say combining the functions. Combining means not adding. We'll see how we are combining the functions. So here we have the definition. Let function f such that a to b and function g such that b to c be two functions. So here we have function f and function g. Then the composition of f and g denoted by GOF is defined as the function GOF such that a to c given by GOF of x equal to g of f of x for all x belongs to a. So let's see how this definition can be explained in a more simple way. Before that, I'll give you a real life example. Suppose there's a student named P. We have a student P. He's writing the board exam. Okay, he's writing the board exam and he's having the roll number. As you're aware, in the hall ticket you get the roll number, right? So he's having the roll number, something like, we'll go for a simple number, 005. Okay, but when after writing the exam, his answer script will have a different code. So let it be A5. Can you say this A5 is related to P? Can we say it's related? See, the student P is being given the number 005 by the board, but when his answer script is evaluated, he is given a different number. So the P is recognized using this number A5, this code A5. Got it? Okay, so let us move on for the definition to understand in a more simple way. Function f. Okay, we have here three sets: set A, set B, and set C. So here we have three sets. A set A is having an element, a random element x. Okay, this is our element x. So when the function f is applied on the element x, we get f of x. Okay, so when the function f is applied on x, we get the function f of x. Next, on the function f of x, on this we are applying the function g. So what do we get? G of f of x. So finally we can say GOF of x. Is it clear? Okay, when you work out, you'll understand more. Okay, so how to understand GOF and FOG? If it is GOF, f is operated first followed by g, and if it is FOG, g is operated first followed by f, and never your GOF is equal to FOG. Okay, theoretically for the timing you'll understand this. When we work out examples, you'll understand more why GOF is not equal to FOG. Okay, when you say it is GOF, when g is applied on f, that is f is operated first and then you operate g. When it is FOG, g is operated first, it is followed by the function f. Let's see, we'll take a simple example, then you'll understand more. Before moving on to example, we'll go back to your lower class, that is we'll go back to your class 9 and 10, where you have learned polynomials. You have learned, right, p of x is equal to x plus 5. Okay, So p of 1, what do? Instead of x, you will be substituting 1. So what do you get? 1 plus 5, that is 6. I guess this all are aware. I need not explain you, and like it's almost clear. P of x is equal to, if your question is p of x is equal to x plus 1, and if the value of x is 1, what do you write? P of 1 equal to 1. Instead of x, you will be replacing it with 1 plus 5, and that is equal to 6, and your final answer is 6. Let's see how we are going to apply this. Okay, we have f of x is equal to, as we write p of x, here we have f of x. F of x is equal to x plus 5, and g of x is equal to x square plus 1. First we'll find GOF. How do we write GOF? G of f of x. How do we write GOF? G of f of x. See, before, when you're writing solution, always you'll write the given. Okay, don't forget to write the given. Okay, here we have written the given almost here. Okay, so first they have asked you to find GOF. So how GOF we write? G of f of x. So first what you will be operating? This f of x. F you will be operating, and then you will be operating g. So what is f of x? Yeah, yes, it is x plus 5. So what do we write? G of x plus 5. Okay, this is almost clear to you all. Okay, how do we write? G of x, GOF is equal to g of f of x, and what is f of x? X plus 5. So instead of f of x, we are writing x plus 5. So g x plus 5. So what is our g? X square plus 1. So instead of x, what you will be writing? X plus 5. Getting? So what is our g of x? X square plus 1. If this x becomes x plus 5, so instead of x, what you will write? X plus 5 whole square. See here, x plus 5 whole square plus 1. As we know, this is of the form of your algebraic identity a plus b the whole square, that is a square plus 2ab plus b square. That is what the final answer is, x square plus 10x plus 26. So here we have found GOF. Now next, what is supposed to find? FOG. Okay, how we'll write FOG? F of g of x. Ulta. Okay, so first you'll be operating g of x, and then it will be followed by f. So what is your g of x? X square plus 1. What is g of x? X square plus 1. So f of x square plus 1 you will be substituting. Then what is our f? X plus 1. So instead of x, what do you write? X square plus 1. Okay, so x square plus 1, and here we have plus 5. That plus 5 we are writing over here. So x square plus 1, I guess x square plus 6. It's almost clear to everyone how you got x square plus 6. Okay, next they have asked you find GOG. GOG is nothing, g of x. So g of x. So what is g of x? X square plus 1, and we know that what is g? X square plus 1 again. So instead of x square, what you will be substitute? Instead of x, what you will be substituting? This whole thing again, that is x square plus 1 whole square. Did you get why you are substituting this? Because instead of x, what do you have? X square plus 1. So this x will be replaced with what? Yeah, x square plus 1 the whole square plus 1. So when you solve it, you get this answer. That is x raised to 4 plus 2x square plus 2. Next we have FOF. That is f of x equal to f of, what is f of x? X plus 5. And what is f again? X plus 5. So instead of x, you will be writing here x plus 5. Okay, so x plus 5 plus 5, that is x plus 10. So I guess finally you all understood. Can you check GOF? What is GOF? X plus 10x, x square plus 10x plus 26. And what is FOG? x square plus 6. Is it equal? We have noticed in the previous section, we have seen that what it was, cough is not equal to fog, and here it is proved. Okay, fine. So we are done with this. Now we'll go for your textbook example. Okay, so it is example 15, page number 12. You just make a note. Okay, let the function f such that, so 2, 3, 4, 5 are the elements, 2, 3, 4, 5, 9, and g such that 3, 4, 5, 9, 2, 7, 11, 15. B, the function, see this is a question, okay, defined as f of 2 is equal to 3, f of 3 is equal to 4, f of 4 equal to f of 5 equal to 5. Okay, it's a question, okay, and g of 3 equal to g of 4 equal to 7, g of 5 equal to g of 9 equal to 11. What are you supposed to find? Gof. How do we write gof? G of f of x. So first let us write all the functions. So we have written, okay, we defined as, and all the given we have to write till here. Okay, so we know that gof is equal to g of f of x. I need not repeat here. So by the definition of composition of function, we know that gof is equal to g of f of x. So first we are supposed to find what g of f of 2. We are going to find g of f of 2. So let's see. So g of f of 2. What is f of 2? 3. See, g of f of 2 we are supposed to find. First of all, we are going to find g of f of 2. So what is f of 2? It's given, it is 3. So instead of f of 2, what you will write? 3. So g of 3. Now what is g of 3? Yes, we have it. G of 3 is 7. I'll repeat. This is clear to everyone. Gof equal to g of f of x. And first what you're supposed to find? G of f of 2. We are asked to find g of f of x. So first value of x is 2. Then 3, then 4, then 5. So first we'll go for 2. So g of f of 2. What is g of f of 2? 3. And we got it 7. So likewise g of f of 3. What is f of 3? 4. So g of 4. What is g of 4? 7. So here we got 7. Next g of f of 4. Right? G of f of 4. So what is f of 4? Here we have 5. So 5. What is g of 5? G of 5 we have 11. Okay, so 11. Next, what is supposed to find? G of f of 5. So what is f of 5? 5. So g of 5, what is g of 5? 11. So we have 11. I guess this was the simplest one. Let's move on to example 16, page number 12. Find gof and fog if f such that r to r, real number to real number, and g, function g, r to r are given by f of x is equal to cos x and g of x is equal to 3x square. Show that gof not equal to fog. This already, now we know that gof is never equal to fog, but as a question we have to prove it. Solution: function f such that r to r, do I need to tell what does r represent? Set of real numbers. And function g such that r to r are given by, so what is f of x? Cos x. What is g of x? Equal to 3x square. So first we are supposed to find gof. So gof is gof equal to g of f of x. So what is f of x? Cos x. So g cos x. So if we write here cos x, what will happen? 3 cos x square. So the way we write is like this. Don't put square on the x. you have to put the bracket and then write the square. That is the correct way of writing. Okay, so 3 cos x square. So the next step, 3 cos square x. So when the bracket goes, you write the square over here, not on above the x. That is the wrong way of writing. This is the correct way of writing, that is cos square x. So we have the answer 3 cos square x. So next we have to go for fog, that is f of g of x. So fog is equal to f of g of x equal to, what is g of x? 3x square. Okay, so f of 3x square. So instead of x we will be having here 3x square. So what will happen, this x will become 3x square. So that is what you have written, cos 3x square. So is cof and fog equal? No, from 1 and 2 we know that cof is not equal to fog. So here we have done with your example 16. Next we move on to example 17. Okay, which is in page number 13. Show that if function f such that r minus 7 by 5 to r minus 3 by 5 is defined by f of x is equal to 3x plus 4 by 5x minus 7 and g such that r minus 3 by 5 such that, to r minus 7 by 5 is defined by g of x equal to 7x plus 4 by 5x minus 3. Then fog is equal to identity function on set A and gof is equal to identity function on set B, where A equal to r minus 3 by 5, B equal to r minus 7 by 5. IA of x is equal to x for all x belongs to A, IB of x is equal to x for all x belongs to B, are called identity function on sets A and B respectively. It's a total confusion, right? But still I'll make it easy, okay? I guess I need not explain you all this. R minus 7 by 5 means the set of real numbers which is not having this element. Which element? 7 by 5 is not there. To r minus 3 by 5. So in this set we don't have 3 by 5, rest all numbers are there. So actually r minus 7 by 5, what it is, actually it's B. This is B, okay. This is our set B, okay. Okay, to r minus 3 by 5. So you all understood this, right? So what is this one? A. So we'll write here. It's given, okay, in the question. I'm not writing myself. Okay, is defined by, so we have f of x defined in this way, okay. And g r minus 3 by 5 to, what is r minus 3 by 5? A. To r minus 7 by 5. What is r minus 7 by 5? B. Defined by g of x 7x plus 4 by 5x minus 3. Then fog equal to IA, cof equal to IB. What is this IA and IB? It's nothing, identity function. Okay. You know what identity function is? Let me explain you. Okay. You remember domain and your codomain? Always your first set is your domain and your second set is your codomain. You remember that? Okay. So if f such that r to r, then f of x equal to x. That is, your f of x is always equal to x in identity function. We'll see that how it is. See, if it is f of minus 2, it goes to minus 2. If your x is minus 2, it goes to -2. Your x is, always your domain is x. Domain consists of elements, which is x, and your codomain consists of the value of f of x. Value of f of x. If this is x, then this is your f of x. Don't forget, because this I have been telling from the beginning itself. Why I am repeating, if by any reason you don't forget it. Okay, so if your x is -2, then f of x is, f of -2 is -2. So f of -1, -1, f of 0, 0, f of 1, 1. So your f of x is equal to x. When in such a way you get a function, that time you call it as identity function. What do you call it? Identity function. Okay, so here actually your domain and codomain are both real numbers. This I need not explain you. This is your domain and this is your codomain. Okay, I guess this is okay. And when you solve it, if you are getting x, the final answer, if you are getting x, that means it is equal to identity function on set t of x. Again, if you're solving it for b, if you're getting it x, so again it will be an identity function. Okay, let's see how it is working. Okay, solution, you write all the given. Okay, see, if you want, you can write, instead of this thing, you can write b to a, and the other case you can write a to b. It's up to you. Okay, but I preferred writing that, but convenient was this one, but still I wrote this. You can make it as per your convenience, no problem. And here you can write within bracket what is a and b. Okay, as here it is written, where a is equal to r minus 3 by 5 and b is equal to r minus 7 by 5. Let's solve. So we have to find what? We have to show that fog is equal to identity function on set A and golf is equal to identity function on set B. Show that this is all given and we have to show that this thing. So for that we have to find fog and golf. So let us go for fog first. Fog is equal to f of g of x. Okay, so what is g of x? 7x plus 4 by 5x minus 3. So let us solve this. So f of g of x we have substituted. What is f? What is f? 3x plus 4 by 5x minus 7. So this whole thing you have to substitute where instead of x. See, instead of this x, what are you substituting? I'll go for here. Instead of this x, what are you substituting? The whole g you're substituting there. 7x plus 4 by 5x minus 3. This whole thing we are substituting here. Plus 4. Plus 4. Same way, 5x, 4x, you will be writing 7x plus 4 by 5x minus 3 minus 7. Okay, should I repeat? I'll repeat just for once. F of g of x. What is g of x? 7x plus 4 by 5x minus 3. And what is f? 3x plus 4 by 5x minus 7. So instead of x, we'll be substituting 7x plus 4 by 5x minus 3 and plus 4. That is this plus 4 of f we'll be writing. When it is fog, you'll be solving, you'll be operating what first? G, and then it will be followed by function f. Okay, so I guess this is clear. When you solve it, you get it. This one, your denominator gets cancelled. Okay, then what is remaining? 21 plus 12 plus 20x minus 12. Here 12 plus 12 and minus 12 gets cancelled, and remaining is 41x. Here again 35x minus 35x gone, so you have 20 plus 21, that is 41. So here we have again getting strike, 41 by 41 is 1. So what is remaining? X. Can we say x is equal to IA of x? Yes, just check. X is equal to I of x, identity function on set A of x, which is equal to fog. Got it? So we got it. See, it looks complicated, but when you solve with proper steps and very cautiously, you'll get your answer. Okay, don't do it in hurry, show patience. But one more thing, you have to be very fast in calculation. If you take your own time, it won't suffice while writing the board exams. Okay, so here we got the first one, we have proved it. Okay, next, GOF equal to G f of x. So first we'll be operating f of x. What is f of x? 3x plus 4 by 5x minus 7. G, what is our G? 7x plus 4 by 5x minus 3. So instead of x, you'll be substituting this whole thing. When you solve it, you get this thing. Again, as said, this thing, denominator gets cancelled. Then here 28y plus 28 minus 28. Okay, so you have 41x. Here again 15x and minus 15x gets right. So you have 20 plus 21, that is 41. So your 41 gets divided, and finally you have x. So again x is equal to IB of x, so which implies that fog is equal to IA and GOF is equal to IB. Now next example will go. Okay, I won't go through all the examples. Next I'll move on to the exercise. Okay, show that if function f such that a to b and function g such that b to c are 1, then GOF such that a to c is also 1. We have learned the mathematical representation of 1 function. If x1 and x2 are the elements of A, set A, and f of x1 is equal to f of x2, then x1 equal to x2. If this is satisfying, then your f is 1. Okay, so we'll go for, so in same way likewise we have to solve it. So what we have to solve for? GOF. We had f and we have g. So GOF of x1 equal to GOF of x2. Okay, what is GOF of x1? How do you write? G of f of x1, g of f of x2. So g of f of x1, g of f of x2, which is equal to f of x1, f of x2. Why we have written f of x1 and f of x2? Because f is also 1 and g is also 1. So obviously f of x1 equal to f of x2. So as g is 1, right? Okay, so therefore x1 equal to x2 as f is 1. Hence GOF is 1. So hence proved. That's all. Thank you.